Hi students, in this video lecture we are going to see the functional units of 8486 microprocessor. The Intel 486 microprocessor can be viewed as an enhanced 8386 with memory cache and floating point unit incorporated on the same silicon cell. Due to the high level of integration, the system designer can implement very powerful system with relatively low chip count. This is the picture of CPU with 8486 on board. This is the architectural diagram of 8486. As the picture illustrates, the 8486 microprocessor consists of a number of system elements incorporated on one chip. The elements that are incorporated on 8486 are enhanced 8386, floating point processor 8387, cache memory controller and 8 kilobytes of cache memory and additional new features. The 8486 consists of the following 6 functional units. They are bus interface unit, cache unit, instruction pipeline and decode unit, control unit, floating point unit, data path unit and memory management unit. The bus interface unit consists of the following functional entities. First one is address drivers and receivers. When 8486 is executing a bus cycle, the address drivers derive the address onto the processor local address bus, and whenever there is a need for the addresses, it takes the address as an input from the processor local address bus through the address receivers. Next is write buffers. These write buffers allow the bus to buffer up 4 write bus cycles from the processor and permitting these write operations to complete execution instantly. Next, data bus transceivers. It is used to get the data onto the processor local data bus during the write bus cycle and take the data into the processor from the local data bus during the read bus cycle. Next is bus size control logic. It is used to sense where the microprocessor is communicating with 8-bit or 16-bit devices. Next is bus control request sequencer. This is used to analyze the order of addressing during the process transfer. Bus control logic is used to control the buses during the execution of a process transfer. Next is cache control logic is used to connect the processor local buses to the external cache controller. Next one is the parity generation. It automatically generates the event parity on the data being written by the microprocessor and checks the validity for the event parity during the read bus cycles. Now let us see the memory hierarchy. The memory in a computer can be divided into 5 hierarchies based on the speed as well as its use. The processor can move from one level of memory to another level based on its requirements. The 5 hierarchies in the memory are magnetic tapes, magnetic disk, main memory, cache memory and register. Next one is cache memory unit. Cache memory is a small sized volatile memory. Faster memory access can be achieved by moving the cache memory unit on board the processor chip. The internal cache introduced by Intel 486 processor provides the additional benefit of limiting the number of memory accesses. The processor only has to access slow external memory when it experiences an internal cache miss. The instruction decode unit consists of the following components: prefetcher, 32-byte code queue, stage 1 and stage 2 decoder unit, execution unit and register write back unit. This is the timing diagram of instruction pipeline. In a single processor clock cycle, the instruction prefetch unit reads instruction in 16-byte lines, and the instruction decode unit consists of 2 stages, stage 1 and stage 2. In stage 1, the opcode is decoded, and in stage 2, the displacement is added to the address to find out the immediate operands, and the execution unit execute the decoded instruction. Once the instruction is completed, the result is written back into the target register. The control unit of 8486 consists of microcode sequencer and microcode control ROM. Microcode is nothing but it is the result of lower level machine language interpretation. It manages the hardware resources at the register level. The microcode cannot be easily modified by the programmer. The main task of microcode is connecting the different registers using ALU to perform the mathematical calculations. The control unit interprets the microcode before given to the instruction decode unit. The control unit is also capable of exception handling, interrupts and breakpoints. The floating point unit consists of two subunits. One is floating point register file and another one is floating point unit. The floating point unit executes the same instruction set as that of 8387 numeric coprocessor. It shares microcode ROM, instruction decode and addressing pipeline logic with data path and integer execution unit. The next unit is Datapath Unit. Datapath Unit consists of several subunits. They are General Purpose Register, Arithmetic Logical Unit. This unit handles all integer and bit oriented math function. Barrel Shifter. This is used by ALU to perform math function. Flag Register. Flag Register consists of two bit fields. One is flag status bit, another one is flag control bit. Flag status bit is used to reflect the previously executed instruction. Flag control bits allow the programmer to alter the operational characteristics of the microprocessor. The last functional unit is the memory management unit. The memory management unit consists of segmentation unit and paging unit. Segmentation unit allows the use of two address components, namely segment and offset. The paging unit organizes the physical memory in terms of pages, and also it is responsible for converting the linear addresses into physical addresses. The memory system for 8486 is same as that of 8386 microprocessor. The major difference is the addition of 8 kilobytes of cache memory and parity checker. Thank you students. Hope you all understood the functionality of each function units of 8486.